Good evening. I am T.Suryagiri Narayana of TTWRDC SRD. Today we are going to look some about solid geometry. Today this session is about solid geometry from onlinemathlearning.com and Wolfram Math World. Okay. So what is solid geometry? In solid geometry, in this lesson, we will look at the geometric properties of 3D solids such as cubes, cuboids, prisms, cylinders, cones, and pyramids and spheres. Like this kind of 3D objects, we are going to look at. And next, what is solid geometry mean? Actually, solid geometry is concerned with three-dimensional space shapes. Some examples of these three-dimensional shapes are cubes, rectangulars. That is like cuboids and solids, prisms, cylinders, and spheres, cones, and pyramids. We will look at the volume formulas and surface areas formulas of the solids. At the end of the this solid topic, and first, the following figure shows some examples of shapes in solid geometry. As you are looking this, these are some of the solids. You can look at here. First one is cube. You can watch the dotted lines there. It indicates the x, y, and z axis. And the next one beside that is rectangular prism. In this also you can find out the three axes, and next to that is triangular prism, and below it the first one the cylinder, and next one sphere, next one cone, and finally pyramid. Like this we have the solid shapes. And next, first we go through the cube. A cube is a three-dimensional figure with six equal square faces. So in this cube, you can find three spaces, like, yeah, you can see here. You can see here. This is nothing but, let us consider length, and this one is, let us consider, this is breadth, and this one is generally height. The volume of the cube is nothing but the product of these three dimensions, that is equal to s cube. As we know, all the sides in the cube are equal, so s into s, that equal to s cube. And next one is the figure above shows a cube. The dotted lines indicate edges of these. Wait a minute. So the dotted lines indicate the edges of these hidden figures you view. If s is the length of one of each side, then the volume of the cube is s into s into s. So the volume of the cube is s cube. As we know generally, the area of each side of a cube is s square. Since a cube has six square shaped sides, its total surface area is 6 times s square. Yes. So the surface area of the cube is nothing but 6 times of s square, that is equal to 6s square. Next, the rectangular prisms are nothing but called as cuboids. A rectangular prism is also called a rectangular solid or a cuboid. In rectangular prism, the length, width, and height may be of different lengths. It's maybe not what we say as certainly they may not be equal, but sometimes we call cube also a cuboid. Okay, it's not uh, pakka that they should be different, so they can be equal also. In case of different sides and heights, we call it as cuboid. The generally the volume of a rectangular solid is that equal to length, that is equal to, this is the length, and this is the width, and this is the height. The product of these three is nothing but the volume of the rectangular solid, that is equal to L into W into H. Okay, next one, So we know the volume of the rectangular prism is L into W into H. So the total area of top and bottom surfaces is equal to for one side. Let us watch here for one side. So let us take this bottom. So for one side that is equal to L into W. So this total area, and next the upper side is nothing but, so this is also length L and this is also width W. So L into W width. So here the area of top and bottom surfaces that is equal to length into width plus length into width. So that is equal to 2 into 2 times of length into width. Similarly, front and back surfaces length 2 into length into height, and similarly two sides surfaces that is equal to width into height, that equal to 2 into width into height. So surface area is nothing but the combination of all the uh, areas of the surface. So that equal to 2 times of length into width plus 2 times of length into height plus 2 times of width into height, that equal to 2 times of what is it, take common 2. So we get length into width plus length into height plus width into height. Next one is prisms. So a prism is a solid that has two congruent parallel bases that nothing but polygons. The polygons from the bases of the prism and the length of the edge joining the two bases is called as height. Okay, so in this prism you can observe that the base we watch here is is a triangle, and the bottom one is nothing but also a triangle. So these two areas should be similar, or they should be congruent, so that when they are congruent only we call it as a prism. So the height is nothing but the distance between these two objects, these two what is say triangles or shapes. So as we watch here, the height is nothing but the distance between these two objects. So if you take here in the other case, it's a pentagon. So it is a pentagon. The distance between these two pentagons is nothing but height. So these two are congruent here also. And next, here the volume of the prism is given by the product of area of its base and the height. So therefore volume of the prism that equal to area of base into height, and the surface area of the prism is equal to 2 times area of base plus perimeter of base times height. Okay, surface area of prism that equal to 2 into area of base plus perimeter of base into height. So if you watch here in this image, so this is the what is the surface area actually means the total surface area of the outer what is a the the upper layer of the any object. It may be a cube or cuboid or anything, sphere or anything. So here the outer surface is nothing but these two triangles. So what is the area of these two triangles? Two times of this triangle area, no? So yes, these two triangles area must be added. And next, this what do you say, the height one, we know height. So find out the surface, what is say, the perimeter of this triangle, so that you can multiply with this height and you can get the total surface area of these, what do you say, three rectangles or anything. So like this we can find out the total surface area of this prism. Okay, so therefore the surface area of the prism equal to 2 into area of base plus perimeter of base into height. Next one is the cylinders. A cylinder is a solid which two congruent circles joined by curved surface. In the previous case, we have seen that the two congruent surface is except the circle. So in this case, it's only the circle. If the two congruent surfaces are circle, then it is nothing but a cylinder. So here the surface area. So the volume of the cylinder equal to pi r square h. So why it's pi r square h means, so what you watch here is a circle. So a circle, what is the area of a circle? Circle area is nothing but pi r square h. So these circles are arranged in a way. So h times of circles combine each other to form a cylinder. So the volume of the cylinder is nothing but, so h times of this area of the circle, so that equal to pi r square h. So like this we can find out the volume of the cylinder. And next, surface area is then equal to 2 into area of circle plus area of rectangle. So surface area equal to 2 into area of circle plus area of rectangle. Yes, yes. So we know the height of the uh, 2 pi r. Okay, okay. So I will draw and see you one thing. So here the surface area of cylinder that equal to 2 pi r square plus 2 pi r h is equal to 2 pi r into r plus h. How this came, I will show you. So if you consider a cylinder, so here I am drawing. So if you consider a cylinder, so here the two circles are added. So what is the area of the circle that equal to 2 pi r square. What is the sorry, area of the circle is pi r square. So here also pi r square. So if you add two circles area, that equal to 2 pi r square. Now if you cut this cylinder half, only the one side of the cylinder, so if you spread it, so if you spread it, you get a, yeah, you get a sheet like this. So if you draw it correctly, you will get a rectangle. So this rectangle is nothing but, this is nothing but the height of the cylinder. So height, so this is nothing but the this is nothing that the perimeter of the circle. So what is the perimeter of the circle? Perimeter of the circle is nothing but 2 pi r. Perimeter of circle is 2 pi r. So that equal to 2 pi r into h, that equal to 2 pi rh. So therefore, yes, the combination of these two is nothing but the perimeter of the surface, total surface area of the cylinder. Okay, so like this we can find out. And next is spheres. So spheres, a sphere is a solid with all its points the same distance from the center. So if you, the distance from this center to here, the surface of the sphere is equal, similar definition of the circle. So what is the definition of the circle? Is nothing but the locus of the point from a fixed point, the whose distance is equal. Okay, so similar definition but in three dimension. So that is the difference between the actually the whole three dimensions and two dimensions. Okay, so here the distance between the center to any point on the sphere is equal, that is equal to r. So that is nothing but sphere. And next, the volume of the sphere that equal to 4 by 3 pi r cube, and surface area of the sphere equal to 4 pi r square. Next, cones. The cones is nothing but a circular cone has a circular base which is connected by a curved surface area and its vertex. A cone is called a right circular cone if the line from the vertex of the cone to the center of its base is perpendicular to the base. So if you watch here, the vertex is perpendicular to the base, the vertex line height is perpendicular to the base. So therefore the volume of the cone that is equal to 1 by 3 pi r cube pi r square h, sorry. So if you watch here, so it is pi r square h. So it is nothing but, so therefore if you calculate this deeply, we can get the volume of the cones. Okay, next, the net of a solid cone consists of a small circles and a sector of a larger circle. The arc of the sector has the same height as the circumference of the smaller circle. Okay, so if you consider this cone, and this is arc 2 pi r, and next, yes, if you cut this cone, if you cut like this and you spread it, so if you cut it, the arc is nothing but 2 pi r, and this is, let us consider this is the sector, and this is the what we say as slant height s. So if you join this in a particular manner, that equal, yeah, if you join this in a radius r circle, you can form a circle. So therefore surface area of a cone equal to area of sector. So this area of sector plus area of the circle, so that equal to pi r square, pi r s plus pi r square, that equal to pi r into r plus s. So like this we can find out the surface area of the cone. And next, pyramids. So pyramids are nothing but, a pyramid is a solid with a polygon base and connected by triangular faces to its vertex. A pyramid is a regular pyramid and its base is regular polygon, and the triangular faces are all congruent isosceles triangles. So if you watch here, the base is in the square shape, and these having these like this isosceles triangles, and uh, therefore these are all are isosceles triangles. So therefore volume of the pyramid is that equal to 1 by 3 area of base into height. So like this we can find out the volume of the pyramid. So as we have seen all this, so the volumes of the cube, rectangle, prism, next cylinder, sphere, cone, pyramid, all these are given in this table. So if you want, you can take a screenshot of this. And next, we are going to the concept sphere intersection. So finally, so what is a sphere intersection? In this image you can find out that two spheres are intersecting each other. So if you take this diagram, so here this is the center of the sphere is at the origin. So if you draw it in two dimension, you can draw it, these both can be drawn similar to the circles, spheres. So let us consider this is origin 0 comma 0 comma 0, and this circle is at a small distance from origin, that is, let us consider d, and center d and 0 comma 0. So the two spheres of radii r and rb along the x-axis centered at 0 comma 0 comma 0 origin and d comma 0 comma 0 respectively. Not surprising, the analysis is very similar to the case of the circle intersection. The equations of the two spheres are, so let us, what are the equations, let us find. So you can watch here, the x square plus y square plus z square, that equal to capital R square. So capital R is nothing but the radius of the first sphere whose which center is at origin, and small r is the radius of the sphere whose center is d comma 0 comma 0. So actually we know what is the equations of the two spheres. So like this we can find out the two equations of the spheres, and now uh, combining or equating these two spheres, so we get the equation x minus d whole square plus r square minus x square, that equal to r square. And next, multiplying through a rearranging given is, now multiplying, so x square minus 2dx plus d square minus x square, that equal to r square minus capital R square. Solving for x, so now solving for x, we get x equal to d square minus r square plus capital R square by 2d. So this is nothing but the, yeah, distance between these two lines. Okay, the intersection of the spheres is therefore a curve lying in a plane parallel to the YZ plane at a single x coordinate, plunging this back to origin gives. So here if we draw a line here, so actually it's a plane, it's a plane parallel to uh, so wait a minute. So this is y axis, this is z axis, and actually this is x axis. So this is x axis. So if we draw a plane of this circle intersecting, so it's actually parallel to, so it's actually so this is y and this is z and this is x. So this plane is actually parallel to yz plane, right? So as you can see here, the intersection of these plane here is parallel to the yz plane. Yes. Now solving the this origin, the sphere having the center at origin capital R circle equation. So now we get y square plus z square equal to r square minus x square. So r square minus so what is x? Substitute this x in this equation. Now we can find out the y square plus z square means this circle equation. So here you get a circle, right? So that circle equation you can find out through this equation. And next, which is a circle with radius, so the radius of the circle intersecting these two spheres is nothing but this one. So if you simplify this, you will get this equation. Okay, so like this you can find out the intersection of the spheres, okay, at origin and at a distance d. Thank you for giving this wonderful opportunity.